Welcome, geometry students, to the homework help video, page 495. Let's go ahead and get started with the homework help video. Let's start off with the numbers 11 through 18. The directions say to state whether you have a minor arc, major arc, or semicircle. Now, I don't want to make this easier than it is, but to be honest with you, it's really simple to know the minor arcs because minor arcs are always denoted or symbolized with two letters. So number 11 has two letters. That's a minor arc. Number 12 has two letters. That's a minor arc. Number 14 has two letters. That's a minor arc. Number 18 has two letters. That's a minor arc. Okay, so those are pretty simple. And if you think I'm making it simpler than I should, I might be. But very quickly, let me give you a couple examples. Remember, a minor arc is any arc smaller than a semicircle. So here's arc CE. Well, that's smaller than a semicircle. Here's arc AB. Well, that's smaller than a semicircle. Here's arc AC right here. Well, that's smaller than a semicircle. So that's why those arcs are minor arcs. Now these further left, 1, 2, 3, 4, those are either going to be major arcs or semicircles. So let's look at ABD. A, B, D. Well, that's a diameter. So arc ABD is a semicircle. Alright? So this would be a semicircle. Number 15, BED. Well, we go from B to E, then to D. Okay? In order of the letters. B to E to D. Well, that is greater than a semicircle because this is a semicircle right here. And you go past the semicircle. Okay? So that is what we call a major arc. Major arc. Number 16, AED. Well, A to E to D. This is a diameter. The endpoints of the arc lie on the endpoints of a diameter. So we have a semicircle. Okay? So number 16 is a semicircle. And number 17, CAE. So C to A to E. Well, guys, that's huge. Look. There's no way it's a semicircle. CAE. That's almost the whole circle. It's about 3/4 of the circle. That is a major arc. It is not a semicircle. Okay. Alright, moving on to numbers 19 through 30. The directions say to find the indicated measures. Alright, now for me, students, on these types of problems here, I really like to go through and just see if I can first find all the angle measurements, okay? So I notice that it says the directions WC and VX are diameters. So this is a diameter here, and this is a diameter here, and they look like diameters. So we're just gonna say if they look like a diameter, then they are a diameter. Now in this problem I'm talking about, now if this is a diameter right here, which it is, we know all three of these angles here have to equal 180. Okay, they have to. So we have one angle that's 45 degrees. We have one angle that's 70 degrees. If you add those two together, you get 115. And so that leaves you with 65 degrees for this angle right here. Now notice right now I'm totally ignoring these problems here. I don't care about these problems right now, okay? That's not a big deal to me. Now, so we have 65 degrees here. And that's not right, is it? Let's see, 20, 0, carrier 1. Yeah, that's correct. Now, students, this right here is a diameter, okay? So this angle here with one dot and this angle here with one dot, they have to add up to 180, okay? So, angle Q has to be 110, okay? Because 110 plus 70 is 180. Now, the only angle left is this angle here, and if you add all these angles up, this angle right here has to be 70 to give you 360. Or you could say there's a straight line here, diameter, so these two angles here have to add up to 180. Either way, you'll get the same answer, okay? So, with that in mind, here we go. Let's see if this helped a little bit, alright? Number 19, they want us to find the measurement of WX. So, the arc length of WX right here has a central angle of 70 degrees right here. So the answer would be 70 degrees. Number 20, arc YZ. Well, Y starts here and goes to C. So here's the end point, go down. Here's the end point, go down. It's this angle here, 45 degrees. So if the central angle is 45 degrees, then the arc is also 45 degrees. Alright, number 22, V, Q, W. So V to Q to W. This is not an arc, this is an angle. So V to Q to W, 110 degrees. Alright, and that's why I thought it'd be helpful to go through first students and just find all the angles quickly and then do the problems, okay? Alright, number 23, arc XY. Well, here's X, here's Y, so here's the endpoints of the arc. So take those endpoints and go straight to the center. And there's the angle we have. The central angle, 65 degrees, gives you this arc right here. So the arc is 65 degrees. Alright, number 25. Angle WQY. So W to Q and then to Y. So W, then to Q. I'm going to use a different color from here on so we can see it a little better. W to Q to Y. So this whole angle right here, well, that angle's made up of two angles, 70 and 65. Add those together and obviously you get 135. So the measure of that angle is 135. Now let's find the measure of angle ZQW. So Z to Q to W. Well, students, that's a straight line. We call that a straight angle. A straight angle always has a measurement of 180 degrees. So the answer would be 180. Alright, moving on to number 28. Arc ZXW. Z to X to W. So the end point of the arc is here, and here we'll notice the endpoints of that arc are also the endpoints of a diameter. So we have a semicircle, and semicircles always have a measurement of 180 degrees. Okay, 180. Moving on to number 29. Arc VWZ. So from V to W to Z. So the endpoints of the arc are from here to here, but be careful when you go like this, okay? Because we're not talking about this angle here. I mean, we can, that's fine, but the arc includes every angle in here except this arc here. So instead of trying to add up all those angles, I would just take 360, which is the total of all of these angles all together, and just subtract out 70 degrees right here. Okay, that's what I would do. And if you take 360 minus 70, then you're going to get 290 degrees. Alright? Oh, I went way out of order, didn't I, guys? I'm sorry. I went 19, 20, 22, 23. Well, I went all over the place. Oh, well. Too late now. Alright, number 21. VQZ. And it is an angle. VQZ. So V down to Q over to Z. 70 degrees. Number 24. Arc VZ. So from V to Z. Right here. Well, here's the endpoints. Here's the endpoints. Go down. Go down. The central angle for that arc is 70 degrees. So the arc measurement is also 70 degrees. Alright. Arc VYX. From V to Y to X. So here's your endpoints of the arc right here. Notice those endpoints lie on the endpoints of a diameter. So we have a semicircle, and a semicircle always has an arc measurement of 360. Excuse me, 180, sorry, 180. Alright, arc XZ, so from X to Z. Alright, so here's the endpoints of your arc, X, Z. By the way, students, how did I know to go this direction and not all the way around? Because if there's two letters, it's a minor arc, so I went with a smaller arc. So here's my endpoints, go down to the center, go down to the center. So this arc includes these two central angles here. So 45 plus 65 is 110 degrees. So the measure of that arc would also be 110 degrees. Okay, so really not too difficult, guys. Pretty simple for the most part. All right, moving on to number 31 and 32. All right, let's see. In 1992, 1,011 shoppers were asked where they purchased their holiday gifts from. All right, let me pause here and reach over and try to get my calculator here. All right, there we go. All right, 1,111 shoppers were asked where they did their holiday shopping at. All right, and 505 said they went to a department or specialty store. So that's 505 out of 1,011 went to department stores, DPT. All right, 354 out of 1,011 went to discount stores. 51 out of 1,011 said they used retail catalogs or television shopping shows. So I'm just going to put catalogs. And then 101 had no idea where they were at, I guess. I don't know. Anyways, they didn't know. So there we go. Alright, unknown. Now, the reason I wrote them as fractions, I kind of looked ahead. I cheated a little bit. It says right here, find the percent of shoppers for each category. Round to one decimal place. So 505 divided by 1,011 is 49.95. It says round to one decimal place. I think I'm going to break the rules here. I'm just going to round to whole percentage just to make it a little easier. I really am, so sorry. That's what I'm going to do. 50%. Alright, okay. Let's come over here. 51 divided by 1,011 gives you 5%. Now, if you're getting, like for this problem back here, if you got 0.4995, remember, move your decimal two places. For this problem here, if you're getting 0.050, move your decimal two places. 354 divided by 1,011, move your decimal two places, 35%. And then if you add 35 plus 5, that's 40, plus 50 is 90. All three of these are 90, so I know this has to be 10% right here. If you want to type into your calculator, feel free to do that, but you're going to get, or you should get, 10%, okay? I got 0.0999, which rounds to 10%. Okay, so there I did it. So I found the percent of shoppers, and I've written them right here. Now the next question, question number 2, says to do this. Question 32 says, determine the arc measure. Determine the arc measure for each category and construct a circle graph. Alright, so we can do that very quickly here. Shouldn't be too difficult. Get a little more room here. Alright, so let's go ahead and get our circle drawn real quick. Now, students, first of all, I've got 50%, so I know 50% is going to be a semicircle, so I'm going to go ahead and draw my line right there, and that looks pretty decent, so I'm going to go ahead and label this department stores. Now, be very careful, students, think about it. We have 35%. Now, what degree would that be? Well, think about it, guys. Take 360 degrees and multiply it by 0.35, and that will give you the degrees that you want. Let me explain that again. You want 35% of 360. Of means multiply. So, if you take 0.35 times 360, you're going to get 126 degrees. So, I know this is 90. Cut that in half. Right there, I know that's 45, that's 135. That's a little too much, so I'm going to back it off a little bit. I'm just estimating, guys. You're welcome to estimate. It's fine. I'm going to back it off to about right there. And I'm personally going to call that about 120 news to us anymore. So there we go, and there we go, and there we go. Alright, good enough. And we're going to call this discount stores. Alright. And then 10% is obviously 36 degrees, okay? Now, if this is 126 right here, guys, then that means this right here has to be 54 degrees. So this whole thing here is 54, alright? Got it? 54 degrees. Because this is 126 degrees. So, 54 degrees. If you cut that in half, that leaves you with 27 degrees. Then cut that in half again, that leaves you with about 13 degrees. We'll cut it in half here. And if you cut that in half again, you'll get about 5%. So I'm going to try to squeeze a little line in there real small. I'm not trying to be perfect, guys. It's not that relevant that I am, but a real small sliver right there. And that's going to be 5%. All right. Let's get that endpoint back on the center there. And we're going to call that 5%. So I'll draw an arrow here. And that's going to be your catalog shopping, I think is what we said. And then this right here left over would be your 10%. Alright, 10%. Which that really looks about right. That would be 36 degrees. Okay, that looks about right. And this is the unknown. So there we go, guys. Really not that difficult. There's our circle graph. Okay. Alright, moving on. Numbers 35 and 36. What is the measure of the arc between consecutive numbers? Now, guys, think about this, okay? Look, you know if you start here and go all the way around, that's 360 degrees, okay? Now, let's count the spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I were to put angles in here like this, now watch carefully. There would be 10 angles. If you don't believe me, if you think I miscounted, count them yourself, okay? That's 10 angles. And they're all equal. We're assuming the numbers are spaced equivalently. So if the whole circle is 360 and you divide that by 10, that's 36 degrees. So each one of these central angles here is 36 degrees. Now if this angle right here is 36 degrees, this angle right here, then what's the arc length from 0 to 1? 36 degrees. So there, I just showed you what one arc length is between the numbers. So what is the measure of the arc between consecutive numbers? That means two numbers side by side, 36 degrees. Now, when a dial moves from 4 to 8, through how large of an arc does it travel? In other words, what is the measure of the arc from 4 to 8? Well, here's 4, right here. And here's 8, right here. So, we have 36 from here to here, 36 from here to here, 36 from here to here, 36 from here to here. We have 4 36s. Remember, I just showed you earlier the space in one number is 36. So 36 times 4 is 144. So the measure of that entire arc is 144 degrees. Alright, moving on to numbers 37 through 40. Now, this one's a little different, students. We have 12 numbers. Thus, if we would divide this thing up into angles, and please trust me, this is accurate, okay? We would have 12 angles. 1, 2, 3, 4. And again, if you don't believe me, if you want to test this, that's fine. Count it on your own, and you'll see there's a total of 12 angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 angles, okay? Now, if I go all the way around this circle, that's 360 degrees. But if I take 360 and divide it up into 12 equal angles, I will get 30. So this little central angle here is 30. So what's the arc length from 1 to 2? 30. So I just showed you now that the arc length between two numbers is 30 degrees. Got it? Alright, so here we go. Now, how many degrees does the minute hand move in 35 minutes? Well, the minute hand would that be? Well, I just showed you from here to here is 30. So how many of those do I have? 1, 2, 3, 4, 5, 6, 7. So 7 times 30, or just count by 30s. 30, 60, 90, 120, 150, 180, 210. So the answer would be 210 degrees. Alright, now the next question says, how many degrees does an hour hand move in 3.5 hours? Alright, now think this through, please, guys. Here's the hour hand, okay? In 3.5 hours, in 3 hours, it'll move from here to here. That's 1 hour. Okay, let's back up and talk about this again. We're talking now about the hour hand, not the minute hand. Every hour, the hour hand moves 1 space. We're talking 3 hours and a half. So, in 1 hour, the hour hand will move 1 space. In another hour, another space. In another hour, another space. So it moves 3 spaces. And then theoretically, not perfectly, but in a half an hour, it'll move half a space. So we got 30, 60, 90, and then half a space here would be 15 degrees. So 30, 60, 90 plus 15 would be 105 degrees. Alright, okay, moving on now to, boy, I keep messing that up, don't I? Moving on now to number 39. Number 39. It says, what is the minor arc measure formed by the hour hand and the minute hand at 124? Alright, so let's get some green lines drawn here. So the hour hand would be here. That's 1 o'clock. And then 24 would be right here. Okay? Now, I will help you if you'll listen, students. Let's come over here where it's not messy. We know from 10 to 11 is 30 degrees. I've already showed you that, okay? So, from 10 to 11, how many spaces do I have? There's 5 minutes, right? 1, 2, 3, 4. So I have 5 spaces. 1, 2, 3, 4, 5 spaces. So take 30 and divide it by a space, and each space is going to be 6 degrees, okay? Got that? 6 times 5 is 30. That should make total sense. I know from 10 to 11, there's 1 hour. I got that. But the minute hand I'm talking about, the minute hand goes from 50 to 51, 52, 53, 54, 55. So the minute hand went from 20 to 21, 22, 23, 24. So the minute hand moved over 4 spaces. So first of all, what we have is an arc that goes from the 1, right? Here's the hour hand. It goes from the 1 all the way down to the 4, and then 4 more spaces from here to here. 1, 2, 3, 4. 4 more spaces, okay? So, from here to here is 30. From here to here is 30. From 3 to 4 is 30. Now, I just showed you over here every minute space between 2 numbers is 6, because from 10 to 11 is 30. That's 5 minutes. So 6, 6, 6, 6, 6, 30, okay? So, one tick, remember we're at 124, so we're 4 spaces past the 4. So 1 space is 6, another space is 6, another space is 6, and another space is 6. So 6, 6, 6, 6 is 24. So 30, 60, 90 plus 24 should be 114, and that's not right. So 30, 60, 90, where did I mess up? 30, 60, 90. I would have to arguably, let's see, 30, 60, 90. Alright, let's see here. Okay, students, I'm back. I kind of paused there to look it over. I'm going to argue with them a little bit. I think what they're saying is the hour hand would not be right on the 1 because it slowly moves around. It slowly moves as this hand moves. And I understand that, but I'm not going to get that technical. To be honest with you, I'm not trying to, make sure that I look like I'm right. I just am not going to get that technical about it. To be honest, I guess they might be saying that it's moved 24 minutes. So that the hour hand has moved, let's see, 24 60th of a space from here to here, of 24 60th of this space here, which is 5 minutes. I'm just gonna off the top of my head maybe, which would give you 2 2 spaces. And that would take 12 away. Yeah, that would do it. That's exactly right. That's it. So that's really being technical. 24 over 60 times 5 gives you 24 over 12. 24 over 12, which is 2. So if this was 2 spaces over, then your arc shrunk by 2 spaces. Take 12 away. I said 114. Take 12 away. That gives you 102. And you do not, so that's, you don't need to do that. I am totally fine with just 30, 30, 30, and then 6, 6, 6, 6. That's totally acceptable. Okay? Alright, and then moving on, lastly, name a time when the minute hand and the hour hands form 180. I'm going to 6 o'clock, man. 6 o'clock. I mean, there's 6, and there's a clock. That's 180. That's the easiest one. Now, they have some other ones here. There's 6 o'clock. There's some other ones. I am not getting into that. That's way too technical, and someone has way too much free time on their hands, okay? Alright, moving on to numbers 41 through 44, okay? Now notice, first of all, question 41 says, what's the radius of the target? Well, look over here. They give us the total length across the whole circle is 48. So from here to here is 48. So the radius would be 12. Half of that, okay, excuse me, would be 24. Half of that. So your radius is 24. Now, is being concentric with transitive? In other words, if I say circle P is concentric with circle Q, and Q is concentric with circle R, does it follow that P is concentric with R? In other words, circle P is concentric with circle Q, and circle Q is concentric with circle R. Can I then say that P is concentric with R? Yes, most definitely, guys. Think about it. If you've got circles and they're concentric, that means they have the same center. So if P and Q have the same center, and Q and R have the same center, then definitely P and R have the same center. So yes, if P is concentric with Q, and Q is concentric with R, then P is concentric with R. And if you've forgotten what concentric is, concentric just means we can say 2 circles are concentric if they have the same center. That's what concentric means, okay? Alright, number 43. Given that BAC is 70, what is the measure of arc DAE? Okay, so BAC right here. My bad, sorry. Angle BAC. So here's angle BAC is 70 degrees. Got it? What is the angle DAE? Well, look, guys, the same angle. Here's D. Then go to A. Then E is the exact same angle, just different letters. So that angle would still be 70 degrees. Now, is BC congruent to DE? Now, this is really a good question, so please pay attention. This is a great question. Arc BC is right here. Got it? Arc DE is right here. Now, if I asked you for the measurement, now listen, students, if I asked you for the measurement of arc BC, you would have to say that it's 70 degrees right here. And if I asked you for the measurement of arc DE, you would have to say that it's also 70 degrees. So both those arcs are 70 degrees, but are they congruent? No, and I can prove it to you. We had a theorem that said, are you ready? Arcs are congruent if they lie. Arcs are congruent, first of all, if they lie in the same circle. So here's the circle for the smaller arc. Here's the circle for the larger arc. Do those 2 arcs lay in the same circle or 2 different circles? Obviously they lay in 2 different circles, so that part fails. The theorem said if 2 arcs have the same measurement, they're congruent. If 2 arcs have the same measurement, 70 and 70, they're congruent. If they lie in the same circle, they don't. Or if they lie in congruent circles, and they don't. Does this circle here look like it's congruent to this circle here? Not on your live. Congruent circles have to have the same radius or diameter. So even though those 2 arcs have the same measurement, no, they are not congruent. Absolutely not. Okay? No. Alright, moving on to number 45. Numbers 45 through 48 read as follows. Find the value of x. Find the value of x. Students, when I look at number 45, it's actually, to be honest with you, a pretty simple problem. I mean, look, this is a diameter. So if that's a diameter, that means this angle here and this angle here have to add up to 180. So wow, I've just got 4x minus 5. Add the other angle plus 2x plus 17. Those two angles together have to equal what? 180. Okay, when you're solving an equation like this, you simplify the left side and the right side. The right side is already simplified. The left side would be 6x, 2x plus 4x, and then positive 12, negative 5, positive 17. If you struggle with that, use your calculator. Now bring your positive 12 over and make it a negative 12. And you're left with 6x equals 168. Then divide both sides by 6, and x equals 28. Alright, 28. Now, did they tell us to find the value of x? Yes, they did. So it is 28. Alright, moving on to 46. Now, this one here, students, it doesn't matter if you go with this diameter here and use these two angles, or if you go with this diameter here and use these two angles here. It really and truly doesn't matter, okay? I'm just going to go with this diameter here, which would include this angle here and this angle here. So these two angles here have to add up to 180, alright? So 4x plus 11x plus 45 equal 180. Now, simplify the right side. That's already done for you. Simplify the left side. 15x equals 4 plus 45. Okay? Put these two together. Bring the 45 over and make it a negative 45. And you're left with 15x equals 135. Alright? Now, divide both sides by 15, and x equals 9. So the answer is 9. Moving on to 47, students. This is really redundant, the exact same thing again. You've got a straight line here, a diameter. So this angle here, this angle here, and this angle here, all three of those angles have to add up to 180, alright? So I have 4x plus 60 minus x plus 2x plus 45. So I've added all three angles together and said they have to equal what? 180. Now if you simplify your right side, you'll get 180. Simplify the left side, you have 3x terms. 1, 2, 3. 4 minus 1 is 3 plus 2 is 5. 5x. Your constant terms are 60 and 45. That's 105. Now, we've simplified the left side. Now bring your 105 over and make it a negative 105. Alright? So now you're left with 5x equals 75. 75. Alright? Divide both sides by 5 and you're left with 15. Alright? So the answer is 15. Moving on to number 48. Now here we have no diameter. This line is not a straight line. It's twisted right there. None of these lines are a diameter. But what I do have is all of these angles adding up to 360. Okay? So I'm gonna create a little bit of room here. I'm gonna slide this up here and get a little more room for a big equation. Okay? So I have 3x plus 5x minus 10 plus 6x minus 15 plus 6x minus 15. And all of that should equal 360. So I've added up all the angles in the entire triangle, and that should be 360. Well, let's see. My right side is already simplified. Here's my x terms. 3 plus 5 is 8, plus 6 is 14, plus 6 is 20. So 20x. Now add up your constant terms. Negative 10, negative 15, negative 15, that's negative 40. Alright? Now bring the negative 40 over. When you bring the negative 40 over, it becomes a positive 40. So now you're left with 20x equals 400. Divide both sides by 20, and x equals 20. Alright? There we go. Well, it was up there somewhere. There it is, 20. Alright, students, let's move on to the last two. Alright, number 49. CA and CB are radii. So this is a radius right here. This is a radius right here. Okay. Which of the following statements is true down here? Now the answer this side here is congruent to this side here. How do I know that? They're both a radius of the circle. They're both radii. So anytime two sides of a triangle are congruent, their opposite angles are congruent. So this angle, this side here is congruent to this side here. So this angle here has to be congruent to this angle here. Okay, so if this is 60, 180 minus 60 is 120. So both of these angles have to be 60. 60, 60, 60. Now, we learned that whenever you have an equilateral triangle, it's equiangular. Whenever you have an equiangular triangle, it's equilateral. So if I have 60, 60, 60, it's an equiangular triangle. If it's equiangular, then all three sides are congruent. So AB has to be equal to CA. It has to be. That is a true statement. Alright? And last but not least, this was pretty tough, so last one and we're done. Please pay close attention, okay? And here we go. PQ and PR are radii. So this segment and this segment, they're each a radius of the circle. Now, if A stays between 0 and 60, non-inclusive, what are the possible values of B? So this angle right here, A, if it stays between 0 to 60, what are the possible measurements for B? Well, I'm going to get rid of all this stuff here. Alright, I'm going to slide this up here. Well, I'm going to try to slide it up here. I'm going to slide this up here. And all I'm going to focus on is the triangle, okay? Now here's my triangle. Look carefully. Here it is. I'm going to make it nice and big so we can see it, okay? Now, this angle here is going to stay between 0 and 60, alright? So this angle here, 0 and 60, okay? Now, I want to show you something. We want to see what happens to angle B. As this angle here changes, what happens to angle B right here? But I want to remind you that because this is a radius, and this is a radius, these two sides are congruent. So if they're congruent, that means this angle has to be equal to this angle, okay? So real quick, let's just put 2 degrees here, okay? If that's 2 degrees, then let's start with 0, even though it can't be 0. Let's just start with 0. Just pretend it's 0, that's 0 degrees. Then these two here have to be, each of them would have to be 90. 90 plus 90 is 180, and then 0. So 90. Now put a 2 here, okay? Well, 180 minus 2 is 178. Divide that in half, and you get 89. Okay? So every time you go up 2, this angle decreases by 1. Let's put a 4 here, okay? Let's put a 4 here. Well, if I put a 4 here, 180 minus 4, because all three of these angles have to add up to 180. So if this angle is 4 degrees, 180 minus 4 is 176. Divide that by 2. Each of these angles is 88. So do you not see what's happening? When the angle up here was 0, each of these angles were 90. When it was 2, each angle was 89. When it was 4, each angle was 88. Okay? So I'm just gonna jump up to I don't know, 50 real quick, okay? Alright, if this angle is 50, then 180 minus 50 is 130. Is that right? Yeah, 130. Each angle has to be 65 degrees. Okay? We're going to continue going on and on, guys. And I think what we're going to see here, I've got to think this through here. Students, as we go along here, notice this angle here has to go from 0 to 60. So I'm going to put 60 in real quick. And obviously, if this is 60, both these angles have to be 60. So it shows you, I took the whole, now think about it, guys. This angle here had to run from 0 to 60. So I started with 0 and saw that both angles have to be 90. And I went all the way up to 60. Both angles would have to be 60. So as this angle here runs from 0 to 60, these two angles down here will run from what? 60 to 90. The biggest is 90 all the way down to 60. So angle B would have to be bigger than 60 and less than 90. Alright? And there it is, guys. Okay? That's it. Hope that makes sense. That's a good question, a good thinking problem. Hopefully this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.